Good morning. Today we will go over the Pythagorean Theorem. The Pythagorean Theorem, let me write that down, is something that you should have learned previously prior to coming to my class. The Pythagorean Theorem is what we use when we have right triangles. It tells us that in any right triangle, we have this equation: a squared plus b squared equals c squared. A, b, and c refers to the length of the sides of that triangle. C is always the hypotenuse. It is always the longest side of the triangle. It is the side that is opposite your right angle symbol. So my right angle box is right here. Across that, that's always C. A and B are the other two legs. It doesn't matter which one is A and which one is B, because we are adding over here. For example, 1 plus 2 is 3, and even if we switch that, 2 plus 1 is still equal to 3. So when we're adding, we can switch these two around. That's why it doesn't matter which one is A and which one is B. So over here on my board, I have an example. I have point A and point B. In geometry, we mostly use Pythagorean Theorem to find the length of those segments on a grid. So here's A and B. There's segment AB. The question is, what is the length of segment AB? Normally, if your line is going horizontal, you can count that. For example, if I'm starting from, I'll move over here, this point to this point, it's a horizontal line down here. You can just count 1, 2, 3, 4, 5. This is 5 units long. But if your line is slanted, you can't do that. So instead, one of our tricks is to turn this into a right triangle. To do that, here's A. What I want to do is from A, I want to draw a line straight across. And from B, I want to drop straight down. And what I mean by straight across and straight down is you follow the grid lines. So here's B. I'm following the grid. I'm on top of the grid line. I drop straight down. Notice these two lines cross down here. So we are looking at this triangle part. So let me go ahead and erase this part of the line that we don't need. We're just interested in that triangle. So our goal now is to figure out how long this side is. I'll call it C. So to do that, since we are now going straight, horizontal, and vertical, we can go ahead and count how long they are. So from A, I go 1, 2, 3, 4, 5, 6 units to the right. And then it goes 1, 2, 3, 4, 5, 6, 7, 8 units up. 6 and 8. Those are the numbers that we will use for the Pythagorean Theorem. So over here, using the Pythagorean Theorem, numbers 6 and 8, I have 6 squared plus 8 squared equals c squared. Squared means you multiply the number times itself. So 6 squared means 6 times 6. 6 times 6 gives me, and I'll do this on the calculator so that everyone can see what I'm typing. 6 times 6 to get me that 36. Down there, 36. Similarly, we do 8 times 8, which is 64. When I am working this, notice I do 36 plus 64 equals c squared. I am leaving c squared alone. That's the last thing I'm touching. Right now, I am focusing entirely on the left side of the equation. So on the left side, let's go ahead and add 36 plus 64, which gets me 100. 100 equals my c squared. So I know c squared is 100, but my job is to find just c. And the way we do that is we take the opposite of squared. The opposite of squared is square root. So we take the square root of both sides. The square root and the squared would cancel each other out, so that on the right side of the equation, all I have now is just c. And on the left side, we do square root of 100, which is 10. On the calculator, square root can be found by pressing second x squared. So that gives you your square root symbol. Type in 100, which gives you 10 as I mentioned. So through the Pythagorean theorem, this tells me that in a triangle with these side lengths 6 and 8, c right here is going to be 10. Alright. So let me erase this and do another example. So what I want to do next is to show you how we can use the Pythagorean theorem backwards. Alright, by backwards what I mean is, if we have this triangle, let me draw one real quickly. Here is a right triangle, and they tell you that this side is 5 and this side is 4. Now our missing side is down here, one of the legs. So we still use Pythagorean theorem, A, B, and C. So let's go ahead and write it down. We have 4 squared plus, this time we don't know what b is, so I'll just leave it as b squared equals c squared. And in this case, c squared is 5, so let me go ahead and replace that with a 5. Apologize for that. 5 squared. So now we can't work with b yet. But what we can do is figure out these numbers. Can I do 4 squared? Yes. Can I do 5 squared? Yes. 4 squared, 4 times 4 gets me 16, plus b squared, because we don't know what b is, equals 5 squared. 5 times 5 is 25. My goal is to get b by itself. This goes back to Algebra 1 now. I am solving for b. Solve for b, I want to get rid of everything around that. So on the left side of the equation, I have that 16 that's being added to b squared. Opposite of plus is minus. That means to get rid of that 16, we minus 16 both sides of the equation. So 16 minus 16, that's gone. On the left side, we are left with b squared. On the right side, 25 minus 16 gets me 9. So b squared equals 9. And we want to get rid of that squared. Just like we did up here, to get rid of that squared, we square root. So take the square root of both sides to get with b equals 30. So this is an example of how we use the Pythagorean theorem in geometry. Most of the time what you will encounter are line segments on a graph, such as this, and they're going to ask you, what is the length of this segment? And one way we can use to solve that is by turning that segment into a right triangle, so that we can count how far we move down. 1, 2, 3, 4. How far we move to the right? 1, 2, 3. Now that we can count 4 and 3, let me move up a bit. 4 and 3. Now we can use set up our Pythagorean theorem. 4 squared plus 3 squared equals c squared. 4 times 4 is 16, plus 3 times 3 is 9, equals c squared. 16 plus 9 gets me 25, equals c squared. At the end of Pythagorean theorem, we square root to get rid of that squared. So square root of 25 is 5.